Hello and welcome to the last problem solving session in Module 4 for the Nature Matter course. And so what we're going to look at now is stoichiometry, so this is a big part of Module 4. So stoichiometry defines the state of the quantitative aspects of a chemical reaction. So in other words, lets you know how much. So questions like, how much reactant do I need to make a certain amount of product? Or if I use so much of this reactant, so much of this reactant, how much product can I expect to make? So we're going to start off stoichiometry by looking at something that you can relate a little better to, and that's a recipe. And so every time you cook using a recipe, you're using stoichiometry, you're using certain amounts of stuff. So if you want to make so much of a meal, you're using so much of this reagent, so much of this reagent to make what you want to make. So in this case, I have a recipe for a cheesecake. So it says I need 3 blocks of cream cheese, a cup of sugar, 5 eggs, and I'm going to make a cheesecake. And so let's look at some problems using this recipe. Okay, so I'm going to write out my recipe. My recipe is my balanced equation, as in chemistry. Okay, so I'm going to put that in a balanced equation form. So recipe is 3 blocks of cream cheese plus 1 cup of sugar plus 5 eggs yields 1 cheesecake. Okay, so now I'm going to use this using dimensional analysis. Now a lot of these problems with cheesecakes, because for some reason it's just easier to think about cheesecakes in chemistry. A lot of these we can do in our heads, but I'm going to go ahead and use the dimensional analysis to show you how you do that. So the first thing says, how many eggs would we need to make 2 cheesecakes? So I'm looking to see what my measurement is. I want to make 2 cheesecakes. So I'm writing down what I'm looking for. Now I'm going to go to my balanced equation, my recipe. To make 1 cheesecake, it says how many eggs would I need? Well, for my recipe, I know to make 1 cheesecake, how many eggs do I need? 5 eggs. So cheesecakes cancel out, and I get that I'll need 10 eggs, 2 times 5. If you only have 3 cups of sugar, how many cheesecakes can you make? So I'm writing down the measurement while I have this problem. So I know I have 3 cups of sugar. I'm converting that to cheesecakes using my balanced equation. So I know 1 cup of sugar is used to make 1 cheesecake. So I'm assuming I have enough of all the other ingredients. So 3 times 1. I can make 1 cheesecake. If you use 3 cups of sugar, how many eggs will you need? So again, write down my measurement. Go to my balanced equation to go from sugar to eggs. So 1 cup of sugar. Requires 5 eggs. So 3 times 5. I need 15 eggs. Now if we go to chemistry, these 3 and 1, that's going to be the number of moles. And so to work problems like this, I need the reaction the number of moles. Well, if I'm not given the number of moles, well then I first have to convert to number of moles. Just like this one, given 24 ounces of cream cheese, I'm given ounces of cream cheese. My recipe has blocks in it. So to be able to use my balanced equation, I need this in blocks. So I first have to do that conversion. So my CC, 24 ounces of cream cheese. So I'm given a conversion right here. 1 block of cream cheese weighs 8 ounces. So 1 block cream cheese weighs 8 ounces. So I use that as a conversion factor. When we do the chemistry like this, it'll probably be grams. I'll be grams of something, and I have to use my conversion using my molar mass to convert that to moles before I can use my balanced equation. So ounces of cream cheese cancel out. And then I get, okay, I'm asked how many cheesecakes, so you can go my balanced equation. 3 blocks of cream cheese, 1 cheesecake. So 24 divided by 8 divided by 3 is going to be 1 cheesecake. So now let's look at the chemistry. Okay, so no longer looking at like the cheesecakes. So remember, these describe the number of moles, not the masses. So if you're given the mass, you have to convert to moles. And so these are the steps you use to solve a typical stoichiometry problem. Convert grams to moles using the molar mass. Convert to moles to the reactant product in question using the appropriate conversion factor from the balanced equation. So what moles you're given, the moles of your product using your balanced equation. And if you're asked to, convert back to grams using the molar mass as a conversion factor. If you're given the moles and you're just asked for moles, just do this one step. Okay. So let's look at our problem. So I have PCl3 plus H2O yields H3PO3 plus HCl. So first thing I want to do is balance the equation. So let's start somewhere. So here I have 3 chlorines. Let's go ahead and put 3 chlorines on the other side. So that gives me, let's see, 3 hydrogens plus 3 hydrogens, 6 hydrogens. So I need 3 in front of that to give me 6 hydrogens. That gives me 3 oxygens. I have 3 oxygens, 1 phosphorus, 1 phosphorus. It's balanced. How many grams of water react with 8 grams of PCl3? So I want to go from PCl3 to H2O. So to do that, I use the balanced equation. But to use the balanced equation, I need moles. So 8 grams PCl3. Okay, 8 grams of PCl3. So I need my molar mass because I need to convert to moles, so I go from one reagent to the other. So look at the atomic masses here. 3 times the chlorine, so I add all those up. So you get 137.32 grams per mole. So I come over here, I'm going to use that conversion factor. So 137.32 grams PCl3 and mole PCl3. So now I have moles. Now I can go from one compound to another compound using my balanced equation. So 1 mole PCl3. And what am I looking for? Grams of water. So I'm going to go to water. So I look up water in my formula. It takes 3 moles of water, reacts with 1 mole of PCl3. And then it says how many grams of water. This would give me moles of water. So molecular weight of water is 18 approximately. So I have 8 divided by 137.32 times 3 times 18. So I get two significant figures, I get 3.1. On the inquiry sheet for stoichiometry, a lot of those just keeps it in moles. So you just, when you get your moles here, you just again use your mole ratio from your balanced equation. You wouldn't even have to do those two steps. So how many grams of phosphorus acid will be produced? So this phosphorus acid here. So again, I'm going to start with 8 grams PCl3. Convert it to moles. One mole of PCl3 produces 1 mole of H3PO3. Now, I want the grams of H3PO3. So I need to look at my molar mass. So again, I'm just looking at my atomic masses of each one of these elements and multiplying by the amount I have. So I get 81.99 grams per mole. So I come over here, 81.99 grams of H3PO3 per mole. So notice here when I use the molar mass, I put it on bottom because I want grams to cancel out. And here where I use the molar mass, I put it on top because I needed moles to cancel out. So remember, your molar mass is in grams per mole. So you get 4.776, so two significant figures, 4.8. So 4.8 grams of phosphorus acid. Let's look a little bit about yields. The moles of product that you calculate from stoichiometry gives a theoretical yield. That's how much is theoretically possible. If you go into the lab and actually do the reaction, that's what's known as your actual yield. Okay. Now, usually when you go into the lab and do the reaction, you'd almost never get all of your theoretical yield. And so what you do is you calculate your percent yield, and that's the percent of the theoretical that you was able to isolate. And so your percent yield is then found by taking your actual yield, divide by your theoretical yield times 100. Theoretical and actual yields are expressed in terms of mass, not moles, and then your percent yields in a percentage. So let's look at this problem. It says aspirin is produced from salicylic acid and acetic anhydride. How many grams of aspirin would you obtain from 4.5 grams of salicylic acid if the percent yield of the reaction was 75%? So the first thing I need to do, how many grams of aspirin would you obtain from 4.5 grams of salicylic acid? So salicylic acid, this is C7H6O3. First thing I want to do is check and make sure my equation's balanced. Carbons, I have 11, 11. Hydrogens, I have 12, 12. Oxygens, I have 6, 6. So it's already balanced. So I need to convert this to moles. This is carbon, hydrogen, oxygen. So you got 138.1. So I come over here, 138.1 grams C7H6O3, mole of C7H6O3. Go to my balanced equation. 1 mole of salicylic acid. 1 grams of aspirin, so I'm asking about aspirin, so that's the C9 compound here. Produces 1 mole of C9H8O4. Remember, there's not a coefficient right there, assumed to be 1, so it's 1 to 1. Now I need to convert that to grams to get the grams of aspirin. You got 180.1. So 181 grams per mole. So I come over here, I need moles on bottom, so I'll put my 181.1 grams on top. Then I get 5.86, somewhere around that up to 5.9. Grams of aspirin. So that's my theoretical yield. So I get that if this reacts completely, the 4.5 grams of salicylic acid react completely, I get 5.9 grams of aspirin. Okay. Now I want to know, I go into this lab and actually do this reaction, I only get 75%. So basically I'm going to take 75% of my 5.9. So percent yield, which is 75%. Decimal form, that'd be 0.75. So actual, my theoretical, which is what I counted out there, would be 5.9. So 75%, 5.9, and I get 4.425, so 4.4. So 4.4 grams of aspirin. So we're going to go ahead and stop there for this lecture over stoichiometry, and then I'll just pick back up and do one more for the limiting reactant instead of combining them both into this lecture. So bye.